Hello, everyone. It is actually very amazing and quite humbling to be giving a talk here today. I mean, funny story is that I might have mentioned this while we were chatting, but I found out I would be presenting just a few days ago. And I didn't have anything prepared, and I didn't plan to give any talks this year. So, it came like, you have to prepare a talk. So I came up really nervous maybe yesterday, but I'm hoping it's coming up a bit better today. Anyway, what happened is that I'm very lucky to be a part of the team that is working on something quite amazing. And a story, how it came to be, is something that I figured I could tell you about. This opportunity also came at a specifically good time, as the company we work for is in the process of transitioning to this amazing thing we built. And speaking of, introductions are in order. As you all probably have noticed, I work for a company called Solarisbank. We do have a virtual booth here at GOTOpia, and you can GOTOpia, and you can drop by it, find out more about what we do, and maybe even win something for a prize draw, which is tomorrow. And me, my name is Armin, as you can see on the slide. And today, I'm here to tell you a story. Why? And more importantly, how we ended up building our own core banking system. Now, before we start talking about banking and stuff, it's important to get the language, and as DDD teaches us, it's supposed to be ubiquitous. So in this specific context, I would like to introduce a couple of terms. First of all, there is something called SEPA. And for those who are not aware, this is a single euro payment area. Essentially, what it is, if you look at from the real world example, it's a huge distributed physical system that makes money movement possible within Europe. There is a second term, which is BIC, that will be mentioned, and it's a bank identifier code. For these technical people, this is like a DNS record. It tells banks, or there is something called the Bundesbank, which is the third term, and for us, it's the institution to which we send files and notify these messages about money movement. And BIC is how it knows where to route this message, where it goes. That out of the way, a long time ago, now I'm telling the story, of course, and every story starts with this long time ago. Well, actually, it was around 5 years ago, but that's a long time ago in the internet time. So in one of the offices just down the street, a small company was founded, and its grand vision was to offer modern-day banking APIs to partners looking to build financial products for their customers. Now, you have to remember that for a long time in human history, and that far in human history, having an API access to a bank was not even a thing. I mean, if you were a corporation, you could probably get some sort of the deal where you would give some money, and they would give you some limited SOAP interface or something. But ability to take these essential banking competencies, combine them, enrich them in novel ways using modern RESTful or something else with an API, that was almost unheard of, especially if you were a startup yourself. Now, at the same time, being a startup and building a bank from scratch, that's not an easy thing to do. One of the early decisions we had to make and was whether do we build a core banking infrastructure or buy something off the shelf. And with extremely limited resources at our disposal at the time, we realized building would not give us significant edge over the competition. So we outsourced it to the best in class, partnering with an established and deeply integrated core banking provider. And this decision helped us immensely. It helped us focus on what mattered and to move towards where we are today. And right now, we are considered as one of the leading banks as a service companies in Europe. But before I move on, I think I owe you another important explanation. I realize most of you are not bankers, and some of you might not know what this core banking thing is. So, I mean, it has core in its name, so it must be important. So let's clarify this. In essence, it is the basic plumbing required to operate a bank. And since this is a tech talk, for us getting an integrated off-the-shelf core banking solution would be as equivalent to kickstarting the software development project with amazing, fully integrated, off-the-shelf enterprise development frameworks, keywords match, with all bells and whistles, with batteries, of course, included. But just like with software development frameworks, there are things that you need to trade in order to gain other, at the time, more important things. Eventually, and if you are really, really, really lucky, you might become successful enough to experience the pain these trade-offs might or might not bring. And we were that lucky. And at some point, we had to pay the price. As usual, first thing tech startup backed by traditional infrastructure hits is ability to scale. While for a classical bank, it is fine to take some time to onboard a customer, open an account, execute a transaction. For a modern tech company, this is just not something you can accept and expect to grow at the same time. Even worse, once we were set on a vendor, scalability we needed long-term was not something we could even buy. In our case, some scalability aspects also affected reliability. Or was it the other way around? Performance degradation on a single business process would leak and affect unrelated business processes. For example, if there were many transactions, account management would become slower. Or if there was a high load on reads, writes would become affected and vice versa. This in turn would also affect the availability. We of course wanted to bring best experience for our partners, but once core banking system was up and running, getting things to change was extremely hard. I mean, what we as a business wanted was software that is suited to us and grows with our business. What we got was not entirely there. I mean, if we could add new features, we built them on our own. But changing the plumbing, the basic stuff, that was not easy or sometimes not even possible. Luckily, in the beginning, these issues were not an extra big deal. We were a startup and the scale of the business has not caught on yet. These issues were something our amazing operations team could handle. Now, somewhere towards the end of 2016, a few of us approached the CTO and proposed to form a small new research team, 3 engineers and a part-time product owner. Our primary job to figure out how to reduce and ideally eliminate coupling to the core banking system within constraints imposed on us by the platform we operated on. What this meant was we could use any technologies supported by the platform and platform team we had. Back then, that meant MySQL and Redis. So, I mean, otherwise, we would have to support it ourselves, the small team. And this meant potentially getting woken up in the middle of the night. And remembering that there were only 3 of us in the team, this was really not something we wanted to do at the time. So we accepted the constraints that we had and started building stuff. And soon, really soon, we started outputting prototypes. And the best thing was, no one demanded we put them into production immediately. So that MVP that people say, oh, you have to build an MVP and that's fine and you can learn from it. Yeah, we had this situation. So we essentially scraped the code and tried again until we got it right, or at least we thought we got it right. By the end of 2016 and beginning of 2017, we delivered the first service. It made it possible to read money movement in the core banking and deliver this data to the software we were running. And this eliminated the need to pull for this information. This kind of system helped the organization, but it was not what we were after. We handed the code to another team for maintenance and continued working on new things. After a couple of tries, we had something we could take and use as a basis of this first new system, first actual new system. We knew we wanted to organize code around concepts of domain-driven design, focusing on business domain and knowledge of domain experts. We, as software engineers, and this will probably come repeated throughout this talk, is we don't know how to build banks. We know how to write software. And we don't want to assume, and we didn't want to assume how processes work. We would ask, we would listen, and we would learn, offering purely technical expertise and only when needed. Event sourcing, we discovered quite soon, was a perfect match for our business domain, as we have to keep the records at all time. Along with CQRS, it fit just like a glove. Now, I'm not going to talk about CQRS and event sourcing. There are better qualified people than me to talk about this. I actually gave a talk some years back around this. So what I will do, I will publish the slides, and you can actually already find the slides at Solarisbank channel, and leave links for those interested to explore more. And I will be happy to talk about these concepts, but this is not the subject of today's talk. Anyway, as time went on, and mid-2017, we became a team of one engineer and one part-time product owner. Luckily, this product owner, besides being a really good domain expert, happened to be an excellent engineer. So that made the work processes a lot easier. For instance, we have this mandatory 4I principle on all processes. This is not a only company policy, this is a legal requirement. So you can imagine how tedious can it be locating someone to review the code in this situation. Anyway, treading lightly, first steps we did was the logical transition from synchronous to asynchronous messaging. In extreme cases, our load would look something like this. We would get requests and some of them would fail or time out. And then operations team would have to manually check if the state we had differed from the state in the system underneath. Not fun at all. This, of course, did not happen every day and was not as extreme as this chart illustrates. This new system acted as a proxy for an important part of the underlying infrastructure we found to be underperforming. These days, in some other context, this is known as flattening the curve strategy, but we do have some other better names. It turned out to be very successful. So other teams operating at higher level of abstraction started using this or similar strategies in their day-to-day operations. It was sufficient for us to dramatically improve quality of the service we were providing without significant resource investment. But more importantly, this proxy took over the responsibility of being the source of truth for this particular competency. We would then synchronize information post factum to the core banking infrastructure, which was still required to perform some other important functions like regulatory reporting. Nevertheless, for us, it started, and when I say it, this core banking system underneath was treated just like another persistence component. If you paid attention, you would realize we made a switch from maintaining an illusion of immediate consistency and suffering because of it to fully embracing eventual consistency and reaping some benefits. Contrary to the popular belief, it turns out banking is just as eventually consistent as nearly every other business out there. Our first service could be described as a small modular monolith, and from a very, very high perspective, it looks something like the diagram shows. Now, I will just shortly go into explanation about the diagram. I mean, it is a school textbook example of how event-sourced and CQRS application would look. So you would have a sort of an API. There is a command handler, and it would accept intents of our customers for something to happen. And these are commands. And these commands would then go into and they would be executed against the domain model, and then we would determine whether the event produced by it can or cannot fit. If it cannot fit, we would return error. If it can, we would persist this event. And now we would have asynchronous processes in the background working on these things. So if it is something to be projected, we would project the state, and then if you come later and query for the state, you would get it in a dedicated part. Or if it was something that we needed to synchronize with someone else, then we would build this specific data model that is required for this something else, and we would send it there. And if we ingested some data from this system underneath, it would also act as a different kind of command, and the entire process would be repeated again. So from a very, very, very high level, when you look at it, it is not at all complicated. But as a side note, an interesting thing we discovered. You know how you start fast and as system grows, it becomes harder and harder to add new stuff. We started slower, but interestingly, as our system grew, adding new things would not become much harder. Occasionally, we would realize a certain component was too complex or not needed at all, and we would refactor it out. Or we figured out generic model classes are making things harder, and we would replace these with purpose-built model classes, making code base larger, but simpler to work with. Separation of concerns. And this was not something special or magic, just the respect to the craft and hard work and not cutting corners to reap short-term benefits. Now, please note, the graph on this specific slide is based on personal assessment of the time required for new features to be added by me and few other engineers. It is here to illustrate a point, and it can't be treated as a fact until such time more peer-reviewable research is performed. Be warned. Anyway, looking at our monitoring system, request-response disparity was something that was immediately clearly visible. At least 99% of requests were queries, asking for data, and only small percentage of them were commands, asking for something to happen. By partitioning our reads from writes, we were now capable to scale these independently. Even better, we no longer needed to reuse generic state for every single purpose out there. We could have state representations built specifically for context where they were needed, and delivered via channel or medium that was most appropriate to hold the state. For a while, we actually had stateful services and discovered why this is a really bad idea. But they worked, and we were able to seamlessly transition to them and from them when we didn't want to use them anymore. Like having an example, dropping a database incident was not something we were at all concerned about, because we could always rebuild the state from scratch. And from a scaling perspective, this meant we now had a system designed to scale horizontally with minimal investment of either time or capital. Now, all of this work was important for us to get to operate at the scale we needed in order to grow. This is not to say underlying system is or was bad. In fact, it is a decent system, just not operating according to the standards we were setting for ourselves. A synchronicity we introduced went a long way to stabilize things and make it possible for us to deal with potential issues timely, while not affecting our partners at the same time, because these are our customers. They are the reason we have a business. And all of this was cool and it was making the organization function closer to the levels that it needed to be at. But for the core banking team, this was just a start. Mid 2018, now counting 7 members, we started working on a new competency. This time it was an in-house payment processing ledger system. Yeah, this is the thing that moves money. Codename Corona. Please note this was sometime before 2020, but we decided not to change the name after all. I might have mentioned building a bank is not an easy task, and planning new project to supplement and eventually replace basic plumbing needs to involve a lot of people. And lots of decisions have to happen relatively fast. We use this technique called event storming successfully in the past on a smaller scale, and decided to get cross-department alignment and map what we need to happen for us to deliver this software fast. What we got was a very nice roadmap, not covering every edge case, but sufficient to start on the implementation without assuming we engineers know what the business needs are, because of course we don't. Tech-wise, the system took a lot of learnings from the first one, but with some twists. Third-party system was now not an underlying core banking system. We operated independently. Instead, we would send messages directly to Bundesbank using something that is in essence a very big distributed physical system, as I mentioned before, and it's called SEPA. We aspired to build a system where each component could operate independently from every other component. We wanted a system where scaling could be done with surgical precision when needed and only where needed. We would be working without previous constraints at the same time. Infrastructure, it's no longer Redis and MySQL. We had a bigger availability of choices, although we still had to be careful because we actually didn't know where we would end up at the end. So we still had to use off-the-shelf technologies that could be applied to different various providers. What happened is that we identified that every component we previously defined became a generic type of service for us now. And we had some core additional cross variants like file processors and file generators, but these are still subvariants of command service or a reactor. Command and query type were interfaces to the system, and they're sitting at the edges of the system respectively, and they handle commands and queries. So these are quite easy to explain. We had this projector and reactor, and these were deep inside, reacting to the projecting events as a result. So just to build a state or to start some different process. Essentially, our reactors are describing business processes, more or less. Now, please note that the processors were where we would get a message from Bundesbank, and yeah, I just mentioned that already, sorry. Anyway, as our previous diagram represented components in a service, this one represented individual service in a bigger, highly distributed system. Main actors, still roughly the same. From what I could gather, the best way to describe this was something close to, but not exactly like, event collaboration pattern. I will link to this in the slide notes. In hindsight, everything now looks super nice and clean, but life rarely works like this. Building complex systems, lots of decisions are made, and not every one of these decisions is a right or optimal one. And of course, we had more than our share of mistakes. We have extensive testing systems, so most of them didn't leak to production, but it served as a super cool learning experience, and we learned and strived to correct these whenever possible. Now, it's an example time for these. Like, First of all, I mean, since banks are a regulated business, we are not free to just go to any cloud provider and start provisioning servers. For us, it doesn't work like this. Offers have to be collected, review contracts needs to be signed, and this took some time. And in the meantime, we started building a new system using PostgreSQL. And interesting aspect of it is that it has this publish notify mechanism. So whenever you persist a new thing, you can say, okay, now you go and publish that this thing has notify all of the listeners that something interesting has happened. And we would send an ID. And then every reactor would just go, oh, something happened, let me go check. And it would just start, okay, this is the ID, give me all events for this ID. It would build the state inside. And it would say, oh, okay, now I see what the state is. And now I can make a decision. And it would make a decision, then would either project a state or it would source another event. However, this introduced one problem. We started doing these services as singletons. So there would be just one singleton doing just one thing. And this, while this worked, it's obvious you shouldn't have just one instance of your service running. That's just basic stuff. So at this moment, we had a choice. We can either increase the complexity, introduce some component for the message coordination, like something like a consumer group of sorts, something that communicates like, oh, I picked up the message, you give up or something. And this is a very complex thing to build, or change the way we deliver messages. So luckily for us, this was a moment where we were quite solid on AWS. So we started using SNS and SQS, and we rewired the entire system. Took us not that long, actually, but at the end, now we have a solid system where every service has at least 3 instances deployed, which works pretty well. And we can scale this. So when we have a larger workload at this moment, we can just say, okay, turn on the auto scaling, and they can be scaled as much as necessary required in order to finish this work. Okay, and second big thing that I could remember is that for a long time we operated on the assumption that eventual consistency would work. And cross-domain communication would rely on the projected data. And this projected data would be a few milliseconds delayed, but it would be fine. However, while you can assume 99% of the cases things will be resolved like this, in a distributed system, you cannot guarantee this. I mean, you can say you guarantee, you cannot guarantee that things will be delivered timely. It's a distributed system. There is a network component. Things can and will go wrong. You can't assume stuff in a distributed system. So eventually, since we couldn't explain like, yeah, it will be okay most of the time to our product people, they said, okay, this is a requirement now of the system. So you can no longer use this eventual consistency thing. You have to go and make assurances of us that this data, specific data is resolved timely. And what we did was maybe not the best idea. So we would, in our services which were operating on one domain, go and consume events from other domain. Actually, this works pretty well. The overall resilience of the system is increased, but it's not worth the complexity that you add, because suddenly one of your domains has intimate knowledge of the other domain. And more services you build using this methodology, the more problems you encounter by increasing complexity so much. At the end, we scraped this idea and moved to, like, we had a special type of service, which in extremely rare cases would now build up-to-date state on request. And this helped us move away from this. And we are still negotiating like which cases are actually deserving and have to be immediately consistent. And what in general I want to say is, while we are not entirely happy with every single decision we made, we knew these things happen, and we have an amazing team which is capable of dealing with literally anything you can throw at them. Which brings us to present time. On September 9th, 2019, Bundesbank issued us a second BIC number connecting the new system to the SEPA network. If we look at the global banking as an example of a distributed system, then having a BIC would be akin to having a DNS entry, so transaction can be routed to correct destination. This enables us to operate new in-house payment processing ledger system completely independent from what we previously had. Roughly the same time, we realized we are going to be running in production team and started adopting DevOps practices, preparing for this very specific moment. We treated most situations on testing and staging as if it was happening with live clients, practicing mitigations, increasing observability, exercising postmortems, and introducing new practices every step of the way. And our testing systems are running at loads we will not see in production for years to come. When we finally went live, we added on-call. So we are building it and we are running it. And our new system went fully live and on production end of 2019. By then, we were 2 teams in core banking, 6 engineers each, 2 product owners, engineering manager, and we were still growing as tech departments, adding new competencies at the accelerated pace. We went through a lot of testing, friends and family phase, and mid-2020, this year, we started onboarding new big partners to this system. And when we say onboarding, we really mean it. On September 9th, 2020, 1 year after we received our second BIC number, and only a couple of months after we started onboarding partners to the system, we are already servicing 20% of full payments across bank total. And just in Q3 this year, more than 1/2 of new accounts were opened using this system. This meant tens of thousands new customers and several times that new accounts, hundreds of thousands of money transfers. And we now have an extremely performant, at the same time, very resilient system running in the public cloud. We can onboard big partners, scale precisely and it well. Not yet entirely effortlessly, but that's coming very soon. We are constantly adding new capabilities to our system, and we are still growing it. And right now, we are looking to add more people to our team. So if interested, there is a Solarisbank channel, or just approach me. Now, I did promise some links. These are the links. And before I go, just one more thing. A few days ago, I had a very nice chat with a fellow speaker here, Uri Goldstein. Back and forth, one thing popped out. Are we open sourcing any of the stuff we are using? And as far as I know, we do want to, and we will be open sourcing some things, but probably not what most people expect. Probably no frameworks or microservice toolkits. This is not because we are forbidden or something, it is because most of the stuff we are using is open source already. Just not by us. We are users arranging these things in our way. The thing is, the stuff we do is better suited to be explained via talk, article, or book. And these books have already been written by people like Dr. Nicole Forsgreen, Jez Humble, Kim Green, Eric Evans, Martin Fowler, Greg Young, and so many others. So, or you can go and see a talk. I mean, many past talks from this very conference served as a source of inspiration for us for the lot of stuff we did. So my final message would be, there is no magic. You will not get stuff for free. Just knowing the fundamentals, some imagination, lots and lots of smart work, and some fun. Because building cool stuff was and always will be fun. Thank you very much.